Hello guys and girls, I welcome you all to the first lecture of this practical building design series, where we will learn to design this real world under construction commercial building project from start to end using latest ETABS software. I have seen a lot of tutors on YouTube who are teaching this software from a hypothetical project, that too incorrect. Building design is a very professional and serious business where people life are entirely dependent on the design engineer. So as a professional engineer, this incorrect teaching practices compelled me to create a practical lecture series from which students can learn how to design real buildings from an under construction project of my own. This course will teach you how to draft proposed building plan, leaving offsets as per the building bylaws as per direction of state authorities, preparing architectural plans such that maximum area is utilized for commercial activity. We will learn how to create correct beam column plan for multiple floors so that we do not face problems later on when we import this plan into ETABS. We will learn to create correct structural model quickly by using ETABS quick draw tools. This commercial building is a 5-story project, contains basement at the bottom for car parking. We will learn to create and apply loads on this retaining walls as well. We will also learn to create ramp for vehicle entry and exit. We will learn to create and apply water loads on this overhead water tank, including the triangular sidewall loads in ETABS with the help of these professional Excel sheets. Dynamic lift load calculations and its application on these shear walls will also be taught in this course. Modeling of beams at an offset to columns, then circular beams with circular slabs will also be taught in this course. The story of this project started when a client of mine approached me for designing a commercial building consisting of 5-story for one of his corner plot at prime location. By visiting the site and taking an aerial photo, it was very clear that it is an irregular shaped plot having roads at two sides. Front side road is larger in size as compared to the left hand side road. Right hand side there is already an existing house, and at the back side there is an empty ground followed by a temple. Now from this aerial photography, it became very clear that this right hand side existing building will create a problem while excavating this plot for basement construction. So we have to provide adequate support to these walls so that they do not flush inside this plot at the time of excavation. Let me tell you that do not take this existing construction at the plot boundary at any of your site lightly. I have seen many of sites where the existing building has flushed inside the construction plot, which then becomes a huge headache for the client later on. The next thing that we need to care is that correct boundary wall measurements. As we can see, this plot is irregular in shape. Majority of plots that you will encounter in your real life will be irregular in shape. This means with measurement of wall length, we have to measure the angles between the walls as well. No matter how perpendicular the walls seems to you at the time of site visit, always measure the angle between the property lines. Take help of triangle rule for measurement of correct angle. Measure all the 3 directions of triangle like this and then find out this angle by using this formula. Cos theta is equal to b square plus c square minus a square divided by 2bc. Without correct angle, you will not be able to draft plot plans correctly in AutoCAD. An incorrect building layout plan will create a lot of problems for you at the time of construction. So it's important that when you visit the site, you always measure the length and angle between the property lines correctly and look around the site to get a general sense of site location so that you can get to know what things will work in your favor and what precaution you have to take early on in design and at the time of construction. Once you have all the data, then you can go to your office and start drafting the plans. Let's shift to the AutoCAD software. Here, as I have measured length and angle between walls, I was able to draft accurate plot boundary layout of this corner property. The angle between the property line came out to be 69 degree, 103 degree, 98 degree. Now in order to create proposed plans like these which contains offset marking as well, we will need area of this plot. We can quickly calculate the area in AutoCAD with area command. Type area and press enter. Start picking up the boundary points of your plot like this. First, second, third and 4th. Once done, press enter. At bottom on the command prompt you can see it reported an area of 10,539 square feet. In meter it will be 979 meters square. Now the way building bylaws has been defined is as follows. The left, right and back side offset will be decided on the basis of area of the plot, and the front hand side offset will be decided by the width of the front side road. As this land is in Rajasthan, we can search Building Bylaws PDF on Google by typing Building Bylaws Rajasthan. For your state Building Bylaws PDF, you can place your state name here and search it, or you can visit your local Nagar Nigam Development Office for the same. Open the website and click on the latest bylaws booklet. If we scroll down on page 36, we can see offset as per the land area is given in this table. For a land area of 750 meters square to 1000 meters square, the offset which needs to be provided for left, right and back side will be 4.5 meter. Roughly it is 14 feet 9 inch. We will provide an offset of 15 feet. Now if we scroll down further to the page 55, we can see the front hand side offset is decided by the road width. Our road width is 60 feet, which is more than 18 meter. So we have to provide a front offset of 4.5 meter again, which will be roughly around 15 feet. Coming back to the AutoCAD plan, here you can see we have provided a 15 feet front offset in front of the proposed building as per the road width rule, and a 15 feet offset is also provided to the left hand side of the plot as per the area rule of building bylaws. To the right side and back side, we wanted to provide an offset of 15 feet, but the client did not agree and he was willing to pay extra fee to the Nagar Nigam authority later on for extra constructed area. So we kept the offset to 12 feet and 6 feet respectively. Generally, relaxation to one or at most two sides of the plot is allowed. But the major side of the plots which is exposed to the road has to follow the offset rules, otherwise the building might get demolished later on. So take this warning seriously. So this is how we create a proposed building plan for any given plot area. Without drafting this plan as per law and as per client's need, we cannot move further to draw the architectural plan for this project or any other project of your own. Once we have the proposed building plan, we can now move on towards the architectural plan. Now in an architectural plan, the way you provide areas should be such that it serves the utility of that space to the maximum, so that later on clients get the maximum output of that property. As this is a commercial property where the front and left hand side roads provides direct visibility access to the 2/3 area of the front plot. So this area should not contain any unnecessary obstructions inside this space. This area should be clear for business activity. That is why we have placed staircase and lift at the back side. The front and side area are clear for commercial activity. The half part of the building will be given to the Reliance Fresh and the half part of the building to the bank. People visiting to the bank or Reliance can enter from the front side door, and customer visiting to the first floor or above floors can take this route and can take help of lift or staircase for the first floor. The two-wheeler parking will be provided to the left and right side of the offset area. As this is a commercial building and will consume heavy electricity, so a separate transformer will be required to support such huge loads. So a separate place for transformer is also marked. As by building bylaws, a minimum four-wheeler parking space has to be provided. We do not have a four-wheeler parking area at the ground level, so we have to provide car parking at the basement level. So we will provide a ramp at the backside for vehicle entry and exit. Keep in mind that providing minimum car parking space nowadays is mandatory, so there is no relaxation in this area. Coming to the column layout, as this is a commercial property, we have to place columns at least 20 feet center to center, so that a clear office or rental furniture and movement space is available between columns. We provided columns at 22 feet center to center grid spacing, so that a clear space of 20 feet is available between column faces. For the front premium side, we have to move these columns to the inclined wall side so that they do not create obstruction. Same has been done with the left hand side columns as well. This corner of the building will receive large span beams varying from 25 feet to 30 feet. So extra columns at these locations has been provided, followed by deeper beams which will be provided at the time of structural modeling in ETABS. This is how you should lay out an initial architectural plan for clients. This architectural plan with column layout was submitted to the client and he agreed. So we moved on for line type beam column plan, which can then be later on imported into ETABS for structural modeling. Here keep in mind that this beam column plan plays an important role for creating complex shaped structural models in ETABS very quickly with 100% accuracy. Learning to make correct beam column plan is very important for a smooth structural modeling experience. You can simply copy paste these columns from the architectural plan to the side. Here do keep in mind that columns can only be in rectangular, square or circular shape. Otherwise ETABS will not recognize it and will not create columns automatically for you. Here the column shape should be closed line figure like this. For beams we only have to create a centerline plan. ETABS will automatically create beams with the help of centerline. As this is a commercial building, the beam layout will be simple, column to column placement like this. Whereas in the case of residential building, we provide beams as per the location of walls and then support it on the columns. I have taught how to prepare this type of complex shape beam column plan in our advanced mega course in much more detail. To know more, visit the FieldReady website. Here do keep in mind that edge beams center line will be placed at an offset to the column center so that once it is casted, the face of the beam will be flushed with the outer face of the column so that later on walls can be placed in a straight bottom to top vertical format. I have seen many YouTubers who place beams at the column center saying that it will not make much difference at the time of construction at site. But from my design experience, it will make a difference that you will learn in advanced mega course. So always draw the centerline plan of the beam as it will be casted on site. You will learn much more about this concept in deep in our advanced mega course. For professional projects where floor plan change with height, we create multiple beam column plan as per floor requirements like this. For importing beam column plan in ETABS, we have to place each floor plan in a separate DXF file format. So for that you can select this plan like this and press Ctrl+C on keyboard. Open a new file, then type UN command and change the units to architectural, precision to 1/8 of an inch, insertion scale to inch. Click OK. Press Ctrl+V on the keyboard to place the layout. Place it in such a way so that the origin is inside the building center so that later on in ETABS rotating the building will become easy. Here do keep in mind that you place columns, beams and walls in separate layers of AutoCAD so that later on ETABS can read these elements easily. You can take help of layer command like this to create a new layer. I have taught how to create complete complex beam column plan in much more detail in our advanced mega course. I have already created DFX file for each floor like this. If you check the layers with layer command like this, you can see there are separate layers for columns, beams, walls and reference points. To check if all the columns are part of column layer, you can take help of quick select tool which was taught in AutoCAD course. Right click here and select quick selection tool. We are interested in the property layer, so select layer from the list. Layer value will be column and then click on OK. Here you can see all the columns are inside the column layer. In the same way you can check for beams, walls, now to save this file in the DFX format, come to the file menu, then click on Save As. Select the .dfx 2018 version from the list and save the file. I have already created these files for basement roof and ground floor plan like this. The ground floor and above stories will have same floor plan, having balcony as the extra structural element. Guys, we have seen in this lecture that how we approach and design proposed building plan, architectural plan, then beam column plan for a real world project. In the next lecture, we will import these beam column plan in ETABS to create the structural model very quickly. See you in the next lecture.